Analog value processing. High level. Level. Transmitter. Low level. Contents page. Use of analog modules. 2. Measuring range modules. 3. Analog module addresses with S7300. 4. Analog module SM335, inputs. 5. Analog module SM335, outputs. 6. Analog input module SM331, 7. Analog value representation and measured value resolution, 8. Analog value representation of different measuring ranges, 9. Scaling analog input values, 10. Unscaling a real number for analog output, 11. Analog value representation for the analog outputs, 12. Exercise, assigning parameters to the analog module SM335, 13. Exercise, assigning parameters to the analog module SM331, 14. Exercise, controlling the level in a tank, 15. Exercise, diagnostic interrupt from an analog module, 16. Use of analog modules. Sensor transducer process physical quantity. Standard. Analog signal. Sensor. Transducer. Pressure. Temperature. Flow. Speed. pH value. Viscosity. Etc. Plus minus 500 millivolts. Plus minus 1 volt. Plus minus 5 volts. Plus minus 10 volts. Plus minus 20 milliamperes. 4. 20 milliamperes. Etc. Mr. Module. ADC. Result. Memory. P. Analog input module. CPU. LP 352. TPQW 368. DAC. PQW. Analog output module. Analog. Actuator. Physical. Quantity. Principle in a production process. There are a variety of physical quantities: pressure, temperature, speed, rotational speed, pH value, viscosity, etc., that need to be processed in the PLC for automation purposes. Sensor measuring sensors respond to changes in the quantity to be measured by linear expansion, angular ductibility, alteration of electrical conductivity, etc. Transducer measuring transducers convert these above-mentioned changes into standard analog signals, such as plus minus 500 millivolts, plus minus 10 volts, plus minus 20 milliamperes, 4. 20 milliamperes. These signals are supplied to the analog input modules. ADC. Before these analog values can be processed in the CPU, they must be converted to digital form. This is done by the ADC, analog to digital converter, on the analog input module. The analog to digital conversion is performed sequentially, that is, the signals are converted for each analog input channel in turn. Result memory. The result of the conversion is stored in the result memory and remains there until it is overwritten by a new value. The converted analog value can be read with the load instruction LP. Analog output. The transfer instruction TPQW is used to write the analog values calculated by the user program to an analog output module, where a DAC, digital to analog converter, converts them to standard analog signals. Analog actuators with standard analog input signals can be connected to the analog output modules direct. Measuring range module. Type of measurement. You set the type of measurement and the measuring range by setting coding keys on the measuring range module. Special modules without coding keys have different terminals for voltage and current measurement. Thus, the type of measurement can be set by wiring the appropriate terminal. Measuring range. The measuring range modules with their coding keys are located on the left module hand side of the module. You must set them correctly before installing the module. The possible settings are A, B, C and D. The settings for the various types of measurement and measuring ranges are printed on the module. Channel groups. On some modules, several channels are grouped together to form a channel group. In this case, the coding key setting applies to the whole channel group. Analog module addresses with S7300. Rack 3 640 2 654 656 670 672 686 688 702 704 718 720 734 736 750 752 766 IM receive power supply 512 2 526 528 542 544 558 560 574 576 590 592 606 608 622 624 638 Rack 2 IM receive power supply 384 2 398 400 414 432 446 448 462 464 478 480 494 496 510 416 430 Rack 1 R power supply IM receive address area. The S7300 has a special address area for analog inputs and outputs, which is separate from the process image input and output tables for the digital modules, PI/PIC. This address area extends from byte 256 to byte 767. Each analog channel occupies 2 bytes. You access the analog modules by means of load and transfer instructions. Example, the statement LP256 reads the first channel of the first module in rack 0. S7400. On the S7400, the address area for the analog modules starts at byte 512. CPU IM 256 2 270 272 2 286 288 2 302 304 2 318 320 2 334 336 2 350 352 2 366 368 2 382 power supply send slot 2 3 4 5 6 7 8 9 10 11 analog module SM335 inputs. Diagnostic interrupt. When the diagnostic interrupt is activated and a hardware fault occurs, such as a power supply failure, a diagnostic interrupt, OB81, is triggered. As well, You must specify in the diagnostics field which inputs are to be monitored. A wire break check is only possible with 4 to 20 mA power inputs. Scan cycle time. The scan cycle time is the time it takes for the module to process, convert, all the activated analog inputs once. The setting for the scan cycle time for AD conversion can be between 0.5 ms and 16 ms. When it has processed all the analog inputs, the module can trigger a hardware interrupt, equals end of cycle interrupt, only if a scan cycle time for conversion longer than 1 ms has been selected. Note: unused inputs must be short-circuited on the hardware and deactivated in the software. Deactivated analog inputs reduce the scan cycle time. Measuring range. When the type of measurement and the measuring range have been selected, module, the necessary coding key setting on the measuring range module is displayed. Example: for the measuring ranges selected in the slide above, the measuring range module must be inserted in position C. Resolution. The analog inputs of the SM335 have a resolution of 13 bits plus sign, the analog outputs 11 bits plus sign. Analog module SM335, outputs. Note: unused output channels must remain open on the hardware, not be short-circuited like the analog inputs, and be deactivated in the software. Analog input module SM331. Parameters. You can set 2 groups of parameters for analog input modules with the HWConfig tool. Module as a whole, diagnostic interrupt. If the group diagnosis checkbox has been activated and a diagnostic event occurs, the relevant information is entered in the diagnostics data area of the module and the diagnostic interrupt, OB82, is triggered. The analog module can detect the following diagnostic events: configuration/parameter assignment errors, wire break, if with wire break check is activated, above measuring range, below measuring range, no load voltage L+. Hardware interrupt when limit value exceeded. If the input value exceeds the range set by the entries for upper limit value and lower limit value, the module triggers a hardware interrupt. Note: only the first channel in a group can monitor the input value for violation of the selected limit values. Individual inputs, type of measurement. When you click this box, the possible types of measurement, voltage, current, are displayed. For unused channels or channel groups, you select the deactivated option. You must connect these channels to chassis ground on the module. Measuring range. When you click this box, the possible measuring ranges for the type of measurement selected are displayed. Coding key setting. A very specific setting of the measuring range module becomes necessary when you select the type of measurement and the measuring range. This is displayed here. The integration time and interference frequency suppression are interdependent. See next page. Analog value representation and measured value resolution. Bit no. Units: 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bit value. December. Hex. VZ. 214. 213. 212. 211. 210. 29. 28. 27. 26. 25. 24. 23. 22. 21. 20. Reso. Lucian. In bits. Plus sign. 80. 1. 128. 8. 40. 20. 10. 8. 4. 2. 1. 64. 32. 16. 9. 11. 12. 13. 14. Representation analog values are represented as the 2's complement. The value is positive if bit number 15 equals 0 and negative if bit number 15 equals 1. Resolution: if the resolution of an analog module is less than 15 bits, the analog value is written into the accumulator left justified. The unused less significant bit positions are filled with 0s. Integration time: the resolution is specified indirectly by selecting an integration time with the HWConfig tool. The following table for the SM331 illustrates the relationship between integration time, resolution and interference frequency suppression. Integration time, resolution, interference frequency suppression, ms, in bits, Hz. 2.59 plus sine bit 416.612 plus sine bit a 60 2012 plus sine bit a 5114 plus sine bit 10. Accuracy resolutions of between 8 and 15 bits are possible, depending on the type of module. Conversion time: the conversion time depends on the conversion procedure used in the module, integrating procedure, successive approximation. The conversion times of the different modules are given in the S7300 manual. Example: the SM344 has a conversion time of only 5 ms for all 4 input channels. 15. 1. 1. One equals 0 or 1, analog value representation of different measuring ranges. Ms.range 4, 20 mA. Current. For example, greater than equals 22.815, 22.810, 20.0005, 20.000, 16.000, 4.000, 3.9995, 1.1852, less than equals 1.1845 units. 32,767, 32,511, 27,649, 27,648, 20,736, 1, 4,864, 32,768. Ms.range 0, 300 ohm. Resistance. For example, greater than equals 352.778, 352.767, 300.011, 300.000, 225.000, 0.000. Negative values. Not possible. Units: 32,767, 32,511, 27,649, 27,648, 20,736, 32,768, 1, 4,864. Ms.range 200 plus 850 degrees Celsius. Temperature. For example, PT 100. Units: 32,767, 10,000, 8,501, 8,500. Minus 2,000, 2001, 2,430, 32,768. Greater than equals 1,000.1, 1,000.0, 850.1, 850.0, minus 200.0. 200.1. 243.0. Less than equals 243.1. Voltage. For example, range. Ms.range. Plus minus 10 volts. Units. Overflow. Greater than equals 11.759. 32,767. Overrange. 11.7589. 10.0004. 32,511. 27,649. 10.00. 7.50. Minus 7.5. Minus 10.00. 27,648. 20,736. Minus 20,736. Minus 27,648. Rated range. Under range. 10.0004. 11.759. 27,649. 32,512. Voltage, current encoding the symmetrical voltage or current ranges. Symmetrical, plus minus 80 millivolts, plus minus 2.5 V, plus minus 3.2 milliamperes, plus minus 250 millivolts, plus minus 5 volts, plus minus 10 milliamperes, plus minus 500 millivolts, plus minus 10 volts, plus minus 20 milliamperes, plus minus 1 V. Results in a rated range of minus 27,648 to plus 27,648. Voltage, current encoding the asymmetrical voltage or current ranges. Asymmetrical, 0 to 2 V, 0 to 20 milliamperes, 1 to 5 V, 4 to 20 milliamperes. Results in a rated range of 0 to plus 27,648. Resistance encoding the resistance ranges. 0 to 150 ohm, 0 to 300 ohm, 0 to 600 ohm. Temperatures are measured with resistance thermometers or thermocouples. Encoding results in a rated range of 10 times the temperature range. Sensor, temperature range, rated range when encoded. PT 100 minus 200 to plus 850 degrees Celsius minus 2000 to plus 8500, Ni 100 minus 60 to plus 250 degrees Celsius minus 600 to plus 2500, thermocouple type K minus 270 to plus 1372 degrees Celsius minus 2700 to plus 13720, thermocouple type N minus 270 to plus 1300 degrees Celsius minus 2700 to plus 13000. Thermocouple type J minus 210 to plus 1200 degrees Celsius minus 2100 to plus 12,000. Thermocouple type E minus 270 to plus 1000 degrees Celsius minus 2700 to plus 10,000. Underflow. Less than equals 11.76. 32,768. Scaling analog input values. 500,0. Example: the level in a tank is to be measured in liters. The measuring transformer was chosen in such a way that 500 liters have an analog value of 10 V. Scaling: the analog module encodes the analog value 10 V as the integer value 27,648. This value now has to be converted to the physical quantity liters. This is known as scaling the analog value. Program standard block FC105 is used for scaling analog values. FC105 is supplied with the Step 7 software in the library standard library in the S7 program TS7 converting blocks. In the analog value at input in can be read in from the module direct or read from a data interface in integer format. Low_lim. High_lim inputs low_lim, low limit, and high_lim, high limit, are used for specifying the limits for conversion to physical quantity. In the example, the reading is scaled to the range 0 to 500 liters. Out the scaled value, physical quantity, is stored as a real number at output out. Bipolar. The input bipolar determines whether negative values are also to be converted. In the above example, memory bit M0.0 has a signal 0 and thus indicates that the input value is unipolar. ret_val. The output ret_val has the value 0 if execution is free of errors. 0,0 27,648. Unscaling a real number for analog output. 27,648. Example: the user program calculates an analog value in the range 0 to 100.0%. This value is to be output via an analog output module. Unscaling. Standard block FC106 is used for unscaling, conversion of a real number from 0 to 100.0% to a 16-bit integer between 0 and 27,648. Out. The unscaled analog value at output out can be transferred in the form of a 16-bit integer to a data interface or to the module direct. Program FC106 is supplied with the Step 7 software in the library standard library in the S7 program TS7 converting blocks. 0,0 100,0 analog value representation for the analog outputs. Output ranges. Voltage 11.7589, 10.0004, 10.0000, 0 to 10 volts, 1 to 5 volts, 5.8794, 5.0002, 5.0000, 1.0000, minus 10.0000, 10.0004, 11.7589, plus minus 10 volts, 0.9999. Output ranges. Current 23.515, 20.0007, 20.000, 0 to 20 milliamperes, 4 to 20 milliamperes, 22.81, 20.005, 4.000, minus 20.000, 20.007, 23.515, plus minus 20 milliamperes, 3.9995. Units. Range. Overflow. Greater than equals 32767. Over range. 32,511. 27,649. 27,648. 0. 6,912. 6,913. 27,648. Rated range. Voltage, current. For symmetrical voltage or current ranges a rated range of symmetrical minus 27,648 to plus 27,648 is converted to plus minus 10 volts, plus minus 20 milliamperes. Voltage, current. For asymmetrical voltage or current ranges a rated range of asymmetrical 0 to plus 27,648 is converted to 0 to 10 volts, 1 to 5 volts, 0 to 20 milliamperes, 4 to 20 milliamperes. Overflow. If the value to be converted reaches the overflow range, the analog output module is disabled, 0 volts, 0 milliamperes. Under range. 27,649. 32,512. Underflow. less than equals 32,513. Exercise, assigning parameters to the analog module SM335. Note: depending on which analog module is in your training unit, you are to do either this exercise or the one on the following page. Goal: to get to know how to change the settings and parameters of analog modules. What to do: change the settings of your analog module to correspond to those in the slide. Exercise, assigning parameters to the analog module SM331. Note: depending on which analog module is in your training unit, you are to do either this exercise or the one on the previous page. Goal: to get to know how to change the settings and parameters of analog modules. What to do: change the settings of your analog module to correspond to those in the slide. Exercise, controlling the level in a tank. Max level of 600 liters equals 10 V at analog channel 0. Level transmitter minute level 50 liters. When the level falls below this, a message is to be output at output Q9.2, Q5.2. Task: the tank has a maximum capacity of 600 liters. The level is measured using a measuring transducer. It is an analog value of 10 V when the maximum level is reached. This analog value is to be converted to a physical quantity, number of liters, using the FC105 block. If the level goes below the minimum 50 liters, the output Q9.2, Q5.2, is to flash until the level is once more 50 liters or more. The first potentiometer on the simulator specifies the level. What to do: 1. Create an FC20 block in the S7 program file according to the task. 2. Call FC20 in OB1 as well. 3. Download the FC20, FC105 blocks and the OB1. 3. Test your program.